I'm happy to be here. My name is Antti Vähäsipilä, and my topic today is to tell you something about the Agile development and Agile product management and how we at Nokia have been trying to marry security management, or more specifically product security management, into that. So because this is not an Agile conference, and because this is applicable to not only to web apps but any software development in general, I'd just like to get a kind of raise of hands here to kind of see that how many of you have actually been involved in an Agile project. So if you could raise your hand if you've done Scrum or Kanban. Almost all of you. So then probably I don't need to go into much details of it all, and actually we had a great presentation about the basics of Scrum already. So if you need more information and background about the actual Agile principles, the handouts that will be available electronically afterwards have some speaker notes that you can refer to for more information as well. So in my books, Agile is something that happens when you're lean. And now the question is, or the question posed to us was that now we are transforming our development into using Agile processes such as Scrum. So how can you make sure that any security aspects we add to the product management project do not break the lean principles? And I think that the key lean principle is that you have to have a very smooth flow of product creation tasks, whatever tasks those are, like coding, testing, or documentation. So you would have to avoid queues. And almost all these things that are here on this slide are about avoiding queues, because a work queue will congest the upstream, so it will kind of create a barrier for work to actually proceed, and it will also starve the downstream of meaningful work. So things like having a security committee or a group that would have to rubber stamp every security-related issue or accept every security risk, those would create a lot of queues, and therefore they would impact negatively any sort of Agile process. Also, we try to make it this process so that they are decentralized and have really local and fast feedback loops. Because if you want to have a product flow that is smooth, the main reason why we would like a smooth flow is that if there's a change in the environment or the targets of the work, we can then very quickly steer the work to the right direction. And having rapid feedback will ensure that this actually happens. And we at Nokia also often split the product security work into two spheres. So one is the security risk management part. So that's really the normal, I mean, it's just like any other business risk management. You have to find the risks or threats, you have to decide how to control them, and then you have to approve the result risk. So yes, that part does include technical activities such as the threat analysis and control selection, which might have to do something with software design. But in the end, most of the security engineering is done then with the development teams. That includes things like secure design and secure coding and security testing. And really, you have to do that whether or not you're in Agile or whether you're doing waterfall or whatever. So I'm going to concentrate here for the risk management of the product creation. And I leave the secure coding stuff to others. You've been hearing a lot about that. Nokia is, for example, a member in a group called SafeCode, which will provide some instructions for security development and so on. So you will, I mean, I'm not going to go much into that part here. And this is my view of what a agile product development machine will look like. Now, probably everybody's got a bit different machine where you work, but there are three main parts to this machine. And the first one is this sort of requirements funnel. So the epic, which you see up there, it's really a user story, which comes from the customer. So it's almost a kind of business case. So it's very high level and not very actionable and not very tangible. And those requirements are then decomposed or split into smaller requirements. And when you are splitting and decomposing them, they become more tangible, more specific, and more like an actual coding task that you could then actually implement. And in the end, what you're left with is a set of tasks or product backlog items. And these then populate the product backlog. So this is the requirements management phase. And then comes the implementation phase. And here I've used Scrum as an example. It could be Kanban or whatever. I don't really care. Most of these practices would probably work pretty well in Kanban as well. So the Scrum team takes tasks from the product backlog, puts them on the sprint backlog, implements them, and then releases them. And the key here is the sprint review, which was also touched by the previous presenters, because that's a good control point for adding security. So we're going to get into that in a moment. And then finally the releasing through continuous integration or similar way. And like I said, this is more of a machine. It's not a process. It's not a waterfall thing that you would first do the requirements management and then do the development, but it's more like every part of this machine is constantly at work. So the requirements management is supposed to feed the backlog all the time, and the sprints should be consuming those backlog items and producing code all the time. So this is the framework. And now there are good papers about all of these and good books about all of these. And I've got some links in the speaker notes if you want to have a look at those. And let's look now at each of these parts one at a time and have a look at what sort of tools we've come up with. So here in the requirements engineering phase, we have a guy called product owner, and that is the customer representative for the teams. So typically there's one product owner per Scrum team. In some cases, one product owner might handle several teams worth of requirements. But this product owner takes these high-level user stories and splits them into a smaller parts. Now, product owners are not necessarily developers, and they are in most cases not aware of security issues. But still, it's clear that we would have to give these product owners some sort of idea that how security could be taken into account while the product requirements are being listed. And this is how we are currently trying to do that. So we have two tools available to these product owners. One of them is actually a kind of proper tool. The other one is basically just a policy decision. So the tool that we have is that we have very generic kind of templated security specific user stories. And for each of these generic stories, we have examples of how you could interpret this in the context of an example. Let's say if the product owner would be doing let's say image sharing program, image sharing feature for a mobile phone, it would have an example of how this generic story could be interpreted in that context. And the idea is that this is a very short list. We have a list of about a dozen high-level security stories. And the list is supposed to be reflecting the actual threats and risks that are typical to your organization and your product which you're developing. And because it's short, we've thought about making it actually a laminated, colorful one-pager that we can give to each product owner, and they can have it on their table, so they will see that. And when they're going through their requirements, they will very quickly learn all those dozen templates, and then they can apply them very easily in their work. The other tool, which is more of a policy decision, is that it should be permissible for the product owners to generate not only positive functional requirements, but also negative abuse cases, or we can call them attacker stories. So if a normal positive user story is of the form that as a user, I would like to be able to do something so that I get some value, an attacker story would be that as an attacker, I shouldn't be able to do something because something bad would happen. And this is it's important for the product owners to be able to write down their worries in these sort of abuse cases, because the product owners, like I said, they probably don't have security expertise, so they do not necessarily have the expertise to actually say that what is the positive functional requirement that you would need to do in order to implement a security feature. But what they can do is that they can express their worries, and this way they can be then written down in the requirements, and later on during the decomposition and splitting these requirements, these can be transformed into positive requirements. So, an example of a generic security story would be that as a user, I want to be protected from unintentionally sharing personal information. So this is a privacy-related user story, and as it happens, this seems to fit pretty well all the privacy requirements, because privacy requirements are not only technical ones, but they have the psychological and legal aspects to them as well. And the product owner in this example, he's trying to produce requirements for a photo sharing application. The product owner looks at this security story template and then comes up with a, based on the other examples that he has, comes up with the requirement that as a user I want that location information is removed from the image metadata unless that I explicitly say that I want to share that data. And then this would be something that would be then fed back to the requirements funnel. So in this picture, in come the epics or features like higher level user stories, and the product owner produces the security stories or attacker stories based on the templates that we give them. During development then, so the Scrum team takes the highest priority backlog items and then produces code. And there's this activity called sprint review at the end of each sprint, and that's the quality gate. I mean, in order for the team to have these tasks on a high enough quality level so that they can say that they're actually done with those tasks, they have to hold the sprint review, and at the sprint review they have a list of criteria, which is often called the definition of done. And the tools that we've offered to the developers are that, first of all, in the definition of done list, you should have the security criteria in addition to every other quality criteria